Okay, now we're going to look at problem B. Find several points that are on the graph of the function y equals 2x squared plus 1. Well, we need to create that graph, and so we're going to do so now. You'll notice that I made the lower part, the x-axis here, a little bit lower. I did that because I just have a little experience in this graph, and I think it's going to head upward rather quickly. But it says to find some points. How do we go about doing that? Looking at this function, we're going to use an xy table, and we're going to use some inputs and some outputs. So for the inputs, x, we're going to use small, easy numbers. I'm going to think of the smallest, easiest number I can. X is 0. And in the equation, what we're saying is that this x is 0. So I'm going to go 2 times 0 squared plus 1. And I'm going to find out what that answer is. 0 squared times 2 is 0 plus 1. And we've got a 1 here. This means that y is 1 when x is 0. I'm going to plug in 1. And so I have 2 times 1 squared plus 1. And 1 squared is 1, times 2 is 2, plus 1 is 3. And so when x is 1, y is 3. We could write these also as points once we've done the table. And these are the points that we're going to graph. And so we're going to see the shape of this graph coming up real shortly. I'm going to do one more rather small number. I'm going to do 2. And so 2 times 2 squared plus 1. 2 squared is 4 times 2 is 8 plus 1 is 9. And I'm going to start by graphing these 3 points. 0, 1, 2, 9, and 1, 3. Okay, 0, 1, 1, 3, and 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this point's way up here, and if you look closely, you can see that this thing is not in a straight line. If I put a straight line on here, these two aren't going to land on this, so I'm going to start building into this a curve. And we're going to learn a lot more about this curve later in this semester. It has something to do with this squared term. But now it's kind of interesting to ask what's going on the other side. So I'm going to pick, instead of 1, I'm going to pick negative 1. And I'm going to put that set of points over here. This is all inputs and outputs for that same equation. I'm going to do 2 more. We already did 0. Now I'm going to do negative 1. Okay, instead of counting up to 1, I'm going to count back on the number line 1. And so I have 2 times negative 1 squared plus 1. But when you square a negative number, it's positive. So this is 1. I'm sorry, negative 1 squared is 1 times 2 is 2 plus 1 is 3. And kind of a crazy thing shows up. This is negative 1, 3. This points right back up here. And we'll do one more. 2. And this time times negative 2 squared plus 1. So this y value is 4 times 2, which is 8, plus 1 is 9. So we go back 2, and we go all the way up to 9. And you can see by having that squared term in there, this graph does some really strange moves and turns. Find several points that are on the graph of this function. Well, we found 5 points. 1, 2, 3, 4, 5. If your curve isn't as smooth as like you think it's perfect, that's fine. Plot the points in the coordinate plane. We did that. Is this a linear function? I'm going to leave that up for you to decide. If you're not sure if it's linear, I need you to look up linear. If you need some help, go to the discussion that many of you are on our website here at Schoology. Support your conclusion. Once you've told whether it is or not, you're going to write the answer. It is linear because, or it is not linear because. Write that in here. Finally, in this section, we have a slightly different problem. It says solve the following equation. How can you use your graph to confirm the solution? Well, solving the equation involves doing the algebra that we learned. There's one last twist with this squared term that you might not recall, so we're going to go through this problem, solving it algebraically now. 9 equals, instead of 2x, it's 2x squared, and I'll get this back on the screen, plus 1. Okay, here we go. Well, We don't have any parentheses. We have no like terms. And so we have this 1 added on, and we'll subtract 1 from both sides. Of course, forming 0 here, and over here doing some arithmetic and finding that that's 8. We have 2x squared equals 8, or 8 equals 2x squared. This is attached by multiplication. We do have an exponent here. We're going to leave that for last. If you go backwards down that, you'll see that exponents are sitting right at the very end. Parentheses, combine like terms, subtraction and addition, division and multiplication, and here's Mr. Exponent. We're going to come to him at the end. Well, we got to get rid of this 2 by division. So 4 equals, and of course this cancels making a 1. 1 times x squared just leaves x squared. Here's the part that you might not remember from last year, and we're not sure you went over it at all. We're going to take the square root. This is the opposite of multiplying something by itself. When you multiply something by itself, it's a squared term. So we're going to undo that, and that looks a little bit like a division sign, but it's not. It's a radical sign. And we're taking the square root of a square. And since I took the square root of the right side, I'll be taking the square root of the left side. We'll be talking a lot about this much later this year when we do quadratics. I bet you can't wait. Here we go. The square root of a square cancels. And so now we have x equals, and you know, if I asked what number times itself makes 4, you'd say 2. Okay? Now that's the primary square root, and we have found an answer to this equation. X should be 2. And now it asks an interesting question. We could plug this 2 back in here and find out if it worked. It turns out it does. There's another answer in here. When you take the square root of something, I'm going to hit you with one more symbol, and it's a little plus or minus. This means that x can be plus 2 or it can be negative 2. And now we're going to use our graph to check out if this is true. So let's find, in fact, you can look at your graph, or you can look, it just so happens that on the 2 tables we used, we had x equals 2, and we had x equals negative 2. And in both cases, y equaled 9. Let's go back to that equation. Remember, if I wrote the equations one on top of each other, here's the function. And here's the equation. And you can tell what the only thing that has changed in these is that y is 9. And that exactly corresponds to when x is negative 2 and when x is 2. So it says, solve the equation. How can you use your graph to confirm it? I'd like you to write about how the graph physically shows you, or I should say visually shows you, the same answers we got using algebra. Again, if you had any trouble with keeping up with this, you're free to rewind. We've got one more section for you here in a moment.